Right now, the leaders of the AI industry are performing a sharp reversal. They are painstakingly rebuilding the manual data structures they spent the last decade trying to automate out of existence. Throughout the 2010s, the prevailing engineering philosophy was that neural networks and sheer data volume would solve the problem of meaning. The consensus was that raw scale would replace the need for hand-built ontologies and explicitly defined logic. When large language models began hallucinating in production, engineers deployed retrieval-augmented generation, or RAG. It breaks text into mathematical vectors, finds chunks relevant to a user's prompt, and feeds them to the model for context. Because RAG was effective at pulling up basic factual snippets, it created a sense of victory. It convinced companies that the unstructured data shortcut was a permanent success and that the era of manual data modeling was over. That confidence holds up until a system is asked to trace a relationship or evaluate a sequence of events. When you ask a pure vector RAG system a multi-hop question, like how a project delay in one region impacted margins in another, the logic breaks. This chart shows the relationship between retrieval accuracy and the number of entities in a query. Performance is stable when dealing with 1 to 3 subjects, but when a query involves 5 distinct entities, accuracy drops toward 0. In production, these gaps create specific vulnerabilities. They break supply chain tracing, miss risks in legal contracts, and hallucinate multi-document summaries. Scaling compute or expanding the context window to millions of tokens doesn't fix this. As the volume of context grows, relevant information becomes diluted, and the model still lacks the ability to traverse relationships. It is essentially looking for a needle in a haystack that is only getting larger. This shows a vector space clustering text by semantic similarity. A glowing search radius grabs nearby points, but no logical sequence connects these dots. To trace how customer A connects to entity B across millions of records, you need a map following exact ties. The required architectural shift is the knowledge graph. It models information as a network, representing specific entities as nodes, and defining the relationships between them as strict, traversable edges. By providing clear, predefined logical pathways, a graph allows an AI to follow a chain of evidence. It swaps mathematical approximations of meaning for explicit, structured logic. This architecture becomes critical the moment an AI transitions from answering questions to acting as an autonomous agent. To plan workflows and track changing preferences over time, an agent needs an organized memory structure. This dual bar chart compares standard vector context against graph-structured memory. The data show clear performance gains, including a 29.6-point increase on temporal reasoning and a 23.1-point leap on complex multi-hop tasks. Recognizing these results, 85% of enterprises are projected to adopt hybrid RAG systems by 2026, running vector search and graph databases in parallel. A portion of the noise surrounding this transition originates from graph database vendors. However, independent research and benchmark evaluations validate that this structure is an engineering necessity. The pivot toward graph RAG is a response to the practical requirements of deploying reliable, autonomous systems that can reason across a history of events. The irony of this shift is that a decade of work to avoid manual data structuring has led developers back to the whiteboard to define their own data models. During that same period, the raw intelligence of foundation models became a commoditized utility. The most capable models in the world are now available to anyone with a credit card. Because the base models are interchangeable, a company's advantage comes from snapping that rented capability into a proprietary ontology. A highly curated, internally governed organizational knowledge graph is the unique asset. Real defensibility resides in the structural map of your own domain, a proprietary asset that remains out of reach for competitors using generic, rented models. Securing that defensibility requires a significant investment in unglamorous data modeling. The hidden bill for this architecture is the labor required to define entities and govern ontologies. Teams must sit down and explicitly define their core subjects, map their relationship structures, and enforce those rules across entire divisions to ensure the AI has reliable data to process. The technology sector routinely declares old, labor-intensive practices dead when a new shortcut appears. But mistaking a shortcut for progress is temporary. Eventually, you have to do the work of building structured logic. If you want to dive into the research behind this shift, check the links in the description for the full benchmark reports. And if this breakdown helped you understand the current AI landscape, like and subscribe for more.